What's up, Algebra 1B? Next thing we're going to do is we're going to learn how to solve quadratics by completing the square. I've found in the years of doing this that kids struggle a little bit with this, so we're going to take this extremely slow. All the ones that we do today are going to be ones that are factorable. The whole point of completing the square is that eventually we'll use it to ones that are not factorable. We're going to get the process down, we're going to keep them very simple, and then we'll slowly increase the difficulty and the ugliness, if you will, of the answers. So we're going to take it step by step, we're going to take it real slow, so I just want you to get the process down for today. So to get you an idea of what's going on, I have a quadratic up here. Solve x squared plus 6x plus 9 equals 0. So the first thing, since we've learned how to solve by factoring with the zero product property, we would look at this and go, okay, it's set equal to 0. I can factor this. I can use that ZPP. So I'm going to set up my parentheses, realize that x and x work. And of course, the two numbers I need that multiply up to 9, add up to 6, clearly 3 and 3. Now, if you notice, what happens is when we go to apply our zero product property, both of these guys are the same thing. So when we solve this, we wind up with two equations that say the same thing. X has to equal 3 or x equals -3. The reason this happened is obviously because both of these quantities, after we factored it, were identical. So what I'm going to do is I'm going to show you an alternative way to solve this rather than factoring it that way. So I'm going to get rid of this. We're not going to use the ZPP here. What we're going to do is we're going to recognize, hey, x plus 3 times x plus 3, that's the same thing as x plus 3 squared. And what that allows us to do is to go back and solve this using the roots that we did before. So I can go, hey, we solve these things. We can solve this by saying, hey, if I take the square root of both sides, don't forget we should put a positive or negative in there when we root. I can solve it that way as well. Square root of x plus 3 squared is x plus 3. The square root of 0 is 0, and positive or negative 0 is not a thing, so it's just 0. Then we can solve from there. Subtract 3, x equals -3. So we wind up with the exact same solution, just a different way to do it. You're probably sitting there going, why would I want to do that when I know the other way? Because when we do completing the square, this is the manner with which we're going to do it. So all you have to recognize right now is that when I factor something and it's the same thing, we can set that as x plus 3 squared and use roots to solve. So here's what we're going to do. We are going to force things to factor this way. We're going to make them factor this way. Now, in order to do that, we need to take a look at our trinomial that we had. There is a relationship between that factorization of x plus 3 squared and these numbers that were here. That relationship is this. If you take this 6, so you're taking your b term, if you take that b term and you divide it by 2, you get that 3. That's this value here. If you take that 3 and square it, you get that 9, which is this value here. So what we're going to do is we're going to force that to happen, and I'm going to show you how to do that. So all you need to recognize right now is that in order to have a perfect square factorization like this guy needs to be this b term divided by 2 and squared. So we're going to write that off to the side here. That b term divided by 2 squared. And keep in mind I'm getting the b term idea because all quadratics in standard form are ax squared plus bx plus c equals 0. It's been a while since we talked about that, so I figured I should mention it. Okay, let's put this to use. So I'm leaving that b over 2 squared right there. So what I'm going to do is I'm going to do one fairly simple. And again, you might look at this and say, hey, that's factorable, but don't get upset right now. We're learning a process. So what I want to do is I want to factor this, and I want it to be a perfect square factorization. So what we're going to do is we're going to force that to happen. So here's how we do that. We're going to say, well, I can factor this, but it's not going to be a perfect square. So I want this to be a new C value. So what I'm going to do, I'm going to put a new C value in there, and I'm going to do it correctly. So first thing I'm going to do is I'm going to say, all right, let's get rid of that C value. Now, I can't just erase it and pretend it doesn't exist. I need to do it correctly. So what I'm going to do is I'm going to add 5 to both sides, and I'm going to make that C value go over there. So now what I'm going to do is I'm going to go ahead and add a new C value that makes this a perfect square. That's where we go back to this. We're going to take that B value, we're going to divide it by 2 and square it, and we're going to put in a new C value that factors as a perfect square. So what we're going to do is we're going to say, take our B, in this case it is 4, we're going to put it over 2, and we're going to square it. Of course, 4 over 2 is 2, and 2 squared is 4. So what I'm going to do is I'm going to go, all right, I'm going to put that new C value in there, plus 4 and plus 4. Now notice what I added to one side, I had to add to the other side. So at this point, I'm going to say, all right, over here, 5 and 4 is 9. That's pretty simple. This guy should now factor as a perfect square. Now, we can get that simply by looking at it and saying, well, what two numbers multiply up to 4 and add up to positive 4? Well, clearly that's 2 and 2, which in this case, x plus 2 and x plus 2 can be written as x plus 2 squared. We can also get that by looking at what was squared, or what we squared to get this 4. Before we squared it, 4 over 2 was 2. That's that value there. Remember that connection I showed. Rewind if you have to. Now at this point I can say, all right, since I have a square isolated, I can solve with roots. I'm going to square root both sides. I'm not going to forget my positive or negative. The square root of x plus 2 squared, that's x plus 2. Root in the square, inverse operations. That's going to equal positive or negative square root of 9 is going to be positive or negative 3. Now I have an equation that I can solve. When I solve this, I'm going to subtract 2 from both sides, and I'm going to wind up with x equals negative 2 plus or minus 3, which I can simplify into 2 solutions. Negative 2 plus 3 is 1, or negative 2 minus 3 is negative 5. That means that the solutions to that original equation are negative 5 or 1. If you want, you can go ahead and factor this guy like we did with the ZPP and double check that and verify it. But I promise you it will work. Let's do another one. Make sure we have the process down. So this time, we're going to do x squared plus 2x minus 15, whoa, minus 15 equals 0. So again, I may look at that and go, hey, that's factorable, but we want to use completing the square. So we want to force this to be a perfect square. So what we're going to do is we're going to say, all right, I want to get a new C value in there that makes this thing a perfect square. So if I'm going to do that, the first thing I'm going to do is I'm going to get rid of that C value. And I'm going to do it mathematically. I'm going to add 15 to that side. I'm also going to add 15 to that side. That takes my C value, takes it over to the other side of the equal sign. So I have x squared plus 2x. 15's of course eliminate, and I get 15. So at this point, I'm going to add a new C value that allows us to factor as a perfect square. Remember, that new C value comes from b over 2 squared. So in this case, my b value is 2. So that's 2 over 2 squared. And of course, 2 over 2 is 1. And 1 squared is 1. So that value that I get at the end, that's the new value, new C value, that I'm going to add in. Of Of course, if I add it to this side, I've got to add it to that side. Now, that forces this into a perfect square factorization. And it's pretty obvious, x plus 1, when I square that, is going to give me that. 1 times 1 would give me the 1, and when I do a 1x and a 1x, I'm going to wind up with the 2x. On this side, I have 16. I could also get that value by noting what was here before squaring it. At this point, I can use my square roots to solve. I'm going to square root this side, and I'm going to square root this side, not forgetting my positive or negative. The square root of x plus 1 squared, that's x plus 1. Root and the square eliminate. That's going to equal positive or negative. The square root of 16 is 4. Again, finishing these off, I'm going to subtract 1 from both sides. I'm going to have x equals negative 1 plus or minus 4. Now, since they're both nice integers, I can simplify that further and say negative 1 plus 4 gives me a 3. And negative 1 minus 4 gives me a negative 5. That is my solution set. Again, this was factorable from the start. You could go back and factor this and double check your answers. But again, we're just learning the process. Let's do another one. We're going to go ahead and do x squared minus 8x minus 20 equals 0. Again, I may look at that and go, hey, I think I can factor that. I think I can solve that. But we're learning the process. We want to solve it with completing the square. Completing the square is all about putting in a new c value that makes this factor as a perfect square. So what we're going to do is we're going to first get rid of that c value and get a new one. Getting rid of it mathematically correctly, we're going to add 20 to both sides. That's going to give me x squared minus 8x equals 20. Notice I leave this space here so I can get my new c value in there. The new c value comes from that process of b over 2 squared. In this case, my b term is negative 8. That's important. Negative 8 divided by 2 squared. Negative 8 divided by 2 is negative 4. And negative 4 squared is 16. So what I'm going to do is I'm going to go ahead and add that new c value in there. And I'm going to add my new c value here. Sorry, my board's only so big. So on this side, 20 plus 16 is 36. X squared minus 8x plus 16, that guy is going to factor as a perfect square. Now, once again, if you need to set up your double parentheses and figure it out, you can, but we can use that little cheater thing here and say it came from this value before we squared it. So I know that this will factor as x minus 4 squared. So if I were to write that out, if I did a negative 4 times a negative 4, I'd get the positive 16, and a negative 4x and negative 4x would give me the negative 8x. I now can solve that with roots. Square root both sides. Don't forget your positive or negative. Square root of x minus 4 squared, it's x minus 4. Positive or negative square root of 36 is positive or negative 6. Solving this, I will add 4 to both sides, and I'll wind up with x equals 4 plus or minus 6. I'm going to start with the 4 minus 6 simply because that is the smaller value, and I like to place my sets in ascending order. 4 minus 6 is negative 2, and 4 plus 6 is 10. Again, if you wanted to, you could have solved this by factoring to double check your answers. Now, Again, we're just learning the process. We're learning how to use completing the square and the process. So don't get worked up that they're factorable and we're doing something different. We're just going to learn a process for when they're not factorable. If you go into Canvas, underneath completing the square, you can pull up the CUDA worksheets. You also have a hard copy of those from the last day we had school. You're going to do numbers 3 through 7. They work out very similar to this. Again, the answers are on the last 2 pages. Give them a try. If you have any questions, email me. Friday, we will have a video up of any questions that we had. We're going to take this slow, and we're going to get through it. Hope that made sense. Email me if you have any problems. See ya.